This is going to be the lightning round. Hopefully the early stuff didn't present you with too many problems. For instance, y equals log base 2 of x plus 1 is so similar to y equals log base 2 of x, with what difference? What have you learned to recognize about this thing? There's going to be a shift. Which direction is it going in? It's going up, right? So therefore, previously we had points for scale, like, well, not points for scale, just coordinates that we went through. Like here, this was 1, 0, right? And also this point over here, which was 2, 1. Do you remember that? Well, I'm going to take both of these guys and I'm going to move them up 1, right? So this point here is going to be 1, 1, right? That's where it came from. Okay. And then this one over here, as I move it up 1, will be at... Wait. What was it for? Moving it up 1, it's right there at 2, 1 at the moment. It would be 2, 2. Thank you. Okay. But as you can see, when you move that upwards like that, your x-intercept is going to change. Now you can work out the exact x-intercept really easily. How do you usually work out x-intercepts?
Y equals 0.
You let y equal 0, so you come over here, one color. You come over here and you say, well, if y equals 0 here, right, then you're getting log base 2 of x plus 1 equals 0, right? Well, can you solve this for me? What do I do? I'm going to subtract 1 from both sides. And now, in order to solve for x, I'm going to need to turn it into an exponential equation, not a log equation. What exponential equation will it be? So that's why, and you can almost see it, right? You see where my points are going to go? You're going to intersect with the x-axis at a half, right? So then when you go ahead, you join up the dots. That's not too bad, okay? You will then notice I've got x and y intercepts. I'm not going to collide with the y-axis. I've got a point for scale. Where's the asymptote going to be? Where was the asymptote before?
0.
It's just that, be more specific, it's a vertical one, so it's x equals 0, right? So it used to be here. And the whole idea of the arrows is to indicate this goes on forever. Well, if you take a vertical line that goes on forever, and you move it up 1 unit, how different does it look? Answer, not different at all, it's exactly the same. So therefore, there's always one. Therefore, I'm going to label it the same. Okay, let's do the rest of these a little bit quicker. Y equals log base 2 of x plus 1, everything inside there. It's not a vertical shift anymore. This plus 1 is actually mucking around with the y. This plus 1 is mucking around with the x. What direction am I going in? To the left, okay? So the same 2 points for scale I mentioned before, which used to be here and here, are now going to be here and here. I'm actually going to pass through the origin, right? And also pass through 1, 1, okay? But this time, your infinite vertical line, now it has moved. Where is it now?
0.
X equals negative 1. Which is why you can see this set of axes has a left-hand side. And that, you get the idea. There you go. That's all you need. Okay, makes sense? Are you following? Okay, now I'm going to skip straight over to this one, which is number 5. Now, number 5, I wonder how many of you noticed, you can kind of be a bit too clever for yourself on this one. You're like, what do I do with that x squared? Oh, wait, I know fancy log laws that can work with that too. What would this be equivalent to if you use log laws to manipulate it? What would you get? You'd get 2 log base 2 of x. Now, this is tricky. I want you to think with me. Last week we talked about domain and range. We talked about it in some depth. Tell me, what are the domain and range of, well, let's just do this one. What's the domain and range of this function here? X has to be greater than 0 and range? All real values, they're all fine. Okay. Now, that's all fine, but when you look at this guy here, and you compare it to this one here, their domains have changed. Numerically, everything is the same. If you take any x value you like say x equals 5. Well, let's pick a better one, 32, because that's base 2, right? You're going to get log base 2 of 32 squared is log base 2 of 1024. This is too many numbers for you to keep in your head, so I'll help you. Right? This is 10. When you have a look at 2 log base 2 of, what was the number I just said? 32. Right? Well, this is 2 times, go on, help me out.
5.
5, which is 10, right? So numerically everything is the same, but this function, the original one, before we mucked with the log laws, this function has a domain that is broader than this one. What's the difference? Can anyone see it? This is 32, right? What would happen if I tried negative 32? Well, if I put it into the original function, which is squared, right? What's going to happen? You're just going to get this, right? Do you see why? Don't move, don't move. Do you see why? Negative 32 times negative 32 is still going to be 1024. But what happens when you put it into your new adjusted function? You're going to have this. What does that mean? This is not defined because look, it's outside the domain. So therefore, what's this guy look like? Last thing, and then you can go. There's the side you're used to. And then there's the side you're not, because guess what? Guess what? What kind of symmetry does this function have? What kind of symmetry do you expect it to have for period 0?
Even.
Look, it's an even function, which is why it reflects.
Whoa.
Thanks everyone.